Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
All right, welcome to Happy Path Programming. It is near the end of April and a beautiful day in Crested Butte, Colorado.
It is.
Today we have with us Valentina Servile. Did I get that at all right?
Actually, yeah, that was the best take of my surname, yes.
Woo! Awesome. Well, it's great to have you. You're coming to us from Barcelona, Spain, and you have written a book, and so we're going to dive into your book about continuous deployment.
Well, you've written, or you're still working on it, right? Or is it actually
it's a bit
at
of
the
a
publisher?
gray area.
Okay.
Yeah, so I've written the entire manuscript, but it is in its final phases of review, and it has yet to go to the final production phase. So you could say I have written a book, but it's not out quite yet.
You're in the production process, and it's coming out from O'Reilly?
It is. It's one of their animal book series. So they're
nice.
really nice ones with the black and white covers with some
Yes.
sort of endangered animal on it.
What's your animal?
It's a bird. It's called a northern fulmar. I actually had to go to Wikipedia to find out what kind of bird it is, but it's kind of like a seagull.
Okay.
Basically.
And were you able to select the animal or select from some choices, or does O'Reilly say your animal, your spirit animal is the pigeon?
So this is actually one of the most common questions I've received since I've started this project. And actually, I was surprised myself to learn that no, if you write a book for the O'Reilly Animal series, you do not get to pick the animal. Actually, the O'Reilly gods choose one for you and you get assigned one. Unfortunately, this didn't work out very well for me because I always thought, when I'm done with this book, what I'm gonna do is I'll definitely tattoo the animal on the cover on myself. However, I already
you don't want that tattoo.
I already have birds all over my arm, and this was yet another bird. So I thought, there goes that plan.
Birds.
I'm not getting another bird on me. That's one too many.
Well, at least it was a bird. Yeah, I think we learned from Luciano that you didn't get to choose your animal.
Yeah.
Yeah, from his book.
Well, it's great to have you. Maybe just start with some background about you and what you work on, and then we'll dive into some book stuff. Continuous deployment.
Sure. So, I work in ThoughtWorks at the moment as a consultant. I'm a tech lead in the Barcelona office, but I've actually just finished a long-term assignment in their Thailand office. So I also got to spend some time in Southeast Asia.
Wow.
I'm not Spanish, even though I work in Spain. I'm actually Italian, as you might be able to tell from the accent and the name. So yeah, I've moved a bit throughout my career, but I've always been a consultant. And so being a consultant, I was kind of lucky enough to work for several companies without having to necessarily change jobs. And I was even more lucky that a lot of those companies were quite mature in their continuous delivery. And in fact, most of them already were about to adopt continuous deployment, or they just had adopted it. And so let's say I got overexposed to this topic, and that's how I ended up writing about it.
Okay. So it is different.
Yeah.
Yeah.
And are you in that consulting role, writing code, doing architecture, everything? What's the job look like?
Well, it's a bit of both right now. So I started just writing code, as a, typical developer career path. Started as a junior developer back in Italy. And then when I started moving on to a tech leadership position, that's when I started also having to, have all those meetings where you plan roadmaps, do boring things like, performance reviews for other people and all that stuff that we don't like doing. I would say now I'm 50-50 on those things. Recently, I got lucky and I'm on a project where I get to write more code than I normally would. But yeah, usually that's the job, 50-50.
Nice. And what language do you usually code in?
I just wouldn't know how to answer that question. I've used so many. I would
all
say
of them, whatever the customer wants.
All of them. Yeah, I pride myself a little bit in being a programming polyglot because basically a lot of the projects I worked on I started without even having ever used that language, and I had to learn it as I was working as a consultant on that project, maybe in 1 week or two of preparation, if I was lucky. So I would say I'm most comfortable maybe with Java-ish languages, kind of Kotlin, Scala, Java itself, good old Java. But I really can do pretty much most programming languages, a bit more modern as well. Maybe not C, C++. That's not my bread and butter, but the most common ones for sure.
Nice. Yeah. Well, it's fun to be in a role where you get to adapt to whatever the customer needs and learn new things along the way. That sounds fun. So let's get into or first, anything else about you that you want to cover?
Yeah, I just got a puppy. So if you hear the dog barking on this podcast, then you know what happened. She's very young, so please be patient with me. Yeah.
No worries. It's always good to have some puppy guests joining us.
Yes.
Yeah.
So it's Friday. Let's kick it off with, should I deploy to production today?
Deploy on Fridays. That is a hard question. So it depends, which is a very consultant answer of me to say. I would say if you're very confident in your quality gates, absolutely. But if you got a planned vacation and you really want to not jinx your weekend, perhaps you can hold off for a little bit. This is especially true with continuous deployment, where maybe I can give a definition right now of it. Yeah.
Great.
So the continuous deployment, which is the topic of my book, as you know by now, basically entails an automated pipeline that takes every single commit from trunk and then deploys it to all environments when the quality gates have passed and are green. And all environments are including production, which means if I decide as a developer today, which is Friday at 6 p.m. for me at least, if I decide to make a new commit and push it to trunk, then that will end up in production in around 20 minutes or however long my pipeline takes to run all the tests and all the checks. If those quality gates are sturdy, which they definitely should be if you are practicing continuous deployment, then deploying on a Friday is something that can be done with minimal worry for your weekend. If you're maybe not quite so sure and you have a lot of manual quality checks before production, then perhaps you could leave it to Monday.
But I would think the problem with deploying on Monday is that it might encourage people to work on the weekend. So maybe Wednesday would be better?
Yeah.
Just whenever you're ready whenever you have confidence. But I think in what you're saying, what you could do is have your code that you think is ready for production. You could have it on a branch on Friday and then just not get a pull request merged or whatever you're using to get onto trunk and leave it on that branch until you get in Monday. And then on Monday, then
trigger. Yeah. We had somebody who had to leave the conference early because they had done a deployment. The team had done a deployment and everything went haywire, and they didn't have an automated rollback system in place. Well, I mean, they could roll back, but for some reason there was a lot of resistance to rolling back. And so our friend ended up having to leave a little bit early.
Yeah.
And so what's your, is that part of your process?
I would say definitely not. So I don't know if this deployment that people were resistant to roll back was including some big new shiny feature that people really, really wanted in production. Is that the case?
I didn't get that impression. I got the impression that there was really no reason other than it hadn't been drilled into people that, hey, if something goes wrong, just roll back to our previous. But you're saying that isn't what your process emphasizes?
Yeah, I guess there's a question around like our rollback, the ability to roll back, is that an essential part of continuous
Oh,
deployment?
yeah. No, the ability, absolutely. I was just asking that question because continuous deployment tends to treat deployment and releases differently. So, as you can imagine, if you have a pipeline that deploys to production, whatever you're putting on trunk, and especially if you're using, let's say, trunk based development associated with it, then you have to find a way to hide the work in progress because not every commit represents a self-consistent feature. And so what happens with continuous deployment is that you tend to rely on some practices to hide work in progress that hide code in a separate execution branch, usually with the use of feature flags, but there's also other techniques that I can talk about more later. So when you got things like feature flags, a rollback can take different shapes. It could be a rollback of a problematic deployment where you've done a code rollout to the machines, and even if that code wasn't really releasing any new feature, maybe it had some performance issue or security issue, and so you definitely can undo the deployment through the automated pipeline. This 100% has to be a capability. But to be honest, the situation that happens more often, perhaps, is that a feature perhaps isn't as well liked as maybe our product owner might think, or maybe it has some issue that wasn't really caught during exploratory testing, and therefore it had been turned on for a subset of users through the feature flag, and it has to be turned back off so that the developers have some time to push some fixes to it. And so you have these two types of reverts, and they should both be quite easy, but definitely the runtime kind with feature flags is by far the easiest one, and it's highly encouraged to do.
Yeah. Because you specifically set up the code to enable or disable that particular feature. So
exactly.
Through an external configuration.
You're designing it. Okay, but I want to back up a little bit and ask a really more fundamental question, because my understanding is that when people talk about CI/CD, that's continuous integration, continuous delivery, and you are talking about continuous deployment, which has a different word. So I'm assuming that there's some fundamental difference. Is that right?
Yeah, that's correct. So obviously we already have books about continuous integration and continuous delivery, and yet here I am writing a new one called continuous deployment. So it's better to explain the difference now so that we can continue with with a foundation here. So I would say definitely the main difference, at least between continuous deployment and delivery, is that continuous deployment basically builds upon all of the good practices of continuous delivery, which says every code change should be a release candidate for production and automatically deployable on demand to any environment. So continuous deployment then builds upon that by saying not only every code change needs to be deployable, it actually needs to be deployed to all environments, including production. So let's say it takes this principle quite literally, because I guess you could argue that continuous delivery and the readiness that it offers to deploy to production is really only theoretical if you don't actually do continuous deployment as well. So it definitely adds that extra step of not only making it automatable, but also really, really automated. And this tends to have some consequences as a developer on your workflow, because then it puts your development and your deployments kind of in lockstep with each other. And suddenly you have to be much more conscious about if you have, say, interdependent systems, which code base are you starting from? Because the moment you push, remember, you're going to affect a contract with another system in production. Therefore, if there's a certain ordering that is required, then you have to actually start your development in the same ordering. And so it has a few considerations like that that are really important. And of course, all of the quality gates and the automated tests and even keeping contracts stable, they are also factors within continuous delivery, but essentially with continuous deployment, they become really mandatory to do. So this would be the main difference, that continuous delivery doesn't require you to push every commit to production, whereas continuous deployment does.
Okay, yeah, it does make sense, but I wonder, maybe you could clarify, what about systems, say self-driving software, where
Yeah.
pushing everything to, I'm nervous about, like, I was with our friend Bill in his Tesla, and he had the early access to the self-driving stuff, and we were trying it out, and the car was getting ready to pull out in front of another car that was coming on, and Bill grabbed the wheel and go, nope. And it's like, yeah, maybe. Well, anyway, what
there's some situations you're saying where you can't. So if you're talking about like a mobile app or
but I mean,
car,
how do you
like
know
an
when
environment
it's ready in that situation? Clearly, what we had wasn't ready, but like,
yeah,
what do you
that's
do?
a great question. So actually, I get this question really often, and it's funny to me because I was just visiting San Francisco and got into a self-driving car myself, and I did have some thoughts on this topic. But yeah, there's definitely
you're like,
a
does this
chapter.
just get a deployment that is going to cause it to crash? Yeah. Am I the canary? Am I in the canary deployment?
Yeah, you're in the canary group for the newest A/B test. No, but in all seriousness, actually, I have dedicated a whole chapter to exceptions. So situations where maybe it's not a great idea to do continuous deployment. And of course, the prime example is always self-driving cars, because that is a matter of life or death. So, perhaps that's something that needs to be manually tested extensively before it is rolled out. That said, all other situations are not usually a matter of life or death, but they still can have pretty bad consequences. So that is the reason why you really need the very sturdy quality gates and very sturdy observability. Another situation where you can't really do continuous deployment is when, as a developer, you have no control over the production environment because, for example, it is just not your own. Say, you mentioned mobile apps, your production environment is a user's device, or even apps that you just install on your desktop, or infrastructure that perhaps you deploy on premises for a client. That production environment is not yours. It is not under your control and influence. Therefore, there will always need to be some sort of consent on the part of a user to, yes, I want to accept a new rollout of this code into my own device. That's definitely not something that I want to question. But go on,
and I guess some of it comes back to how you actually do your trunk-based development, or how you actually manage commits getting to the head. And in some cases, you probably could have a branch that everyone is essentially committing to or doing pull request to, and then there's some other stage that would take that branch with all of the work from many developers on some time-based schedule or some other external decision that would then take that branch and merge it to the head, to the main branch, and then that would have the continuous deployment of being able to then actually cause the update to the production systems or something. Is that an approach that you see, or is generally every developer getting some change set onto the main branch and that kicking off the continuous deployment?
Yeah, so I would say obviously there's many branching strategies that people use, and they usually tend to get into very heated arguments about which one is best. I think, though, personally, if you're practicing continuous deployment, you should tend to practice continuous integration as well, which means to integrate changes at the very least once a day on the main branch. Um, this is because basically, even though it's a bit counterintuitive, there is more risk in using branches when you deploy really frequently. Because what happens when you're using especially long branches is that commits kind of accumulate and start forming big batches. So then once that commit is merged, what's going to happen is that it's going to, first of all, integrate with a bunch of other changes in ways that perhaps you don't expect and might cause a messy merge with some undetected regressions going on there. But also, let's say that even without any merge conflicts, you're just pushing a batch of commits to production all at once without integrating anything. Every line of code can potentially represent an issue in production, if we're pessimistic. So let's say the more lines of code are in your delta of changes that you're applying to production, then the more issues could surface. And then those issues could be unrelated to each other, making debugging more difficult. You have much more code to sift through if you suddenly have a production issue as a result of the deployment. So in short, what I would say here is that, yes, there are different branching strategies, but I would definitely favor the ones with the least time between commit and deployment.
Oh, sure. Because, yeah. The way that I think about it is the longer you wait to experiment, the more changes you've made, and you don't know which of those changes, in your, whereas like, oh, I tweaked this line of code. Oh, something went wrong. I know automatically that it was that line of code. Whereas if like I'm bringing in a whole bunch of code, something went wrong. Well, could be all of these things.
It's a lot harder
to
diagnose.
It could be any of these 3,000 lines since the last deployment. This actually happened to us. So with continuous deployment, one time we made one production deployment, which immediately caused the production cluster of machines to instantly have CPU at 100% and start dying and start getting replaced obsessively. Fortunately, we had actually just pushed literally just one line of code.
You knew exactly where the problem was.
Yeah, and that line of code, to make things even more funny, was just a system out print line, which we would have never suspected would have been an issue. It turns out that if we were not using the proper logger, then that was clogging let's say the queue that was putting all the logs in the system in the standard output. And so the machines which were exposed to really high traffic, they were suffering as a result of not using the proper logger. Now, if I had seen this line buried in a commit of like 3,000 lines, I would have never suspected that that was the issue. It would have taken me ages. But because there was only just this one, that was incredibly easy to diagnose, even if we had no idea that this would cause the machines to suffer. Yeah. So yeah, this is a very practical example, but it was definitely funny for us to figure that out.
So there's some of this that's about making the surface area for diagnostics smaller, and that's very helpful when something goes wrong. And then I think there's another side which is about taking risk and trying to reduce or spread it out in a different way. So back in the old days when we would do these like massive deployments once every 6 months or once every 2 years in some cases, there was so much accumulated risk, and it required so much testing to validate that this massive change was going to not break anything. And you look at that as this like accumulating all this risk and then having to do a lot of things to try to mitigate that risk all at once. And instead, what you're saying with continuous deployment is how can we take that risk and spread it out over much smaller increments to maybe the overall risk doesn't change, but at least we've reduced the risk of any individual change.
Maybe this is the solution to the problem of the term technical debt, because I don't know if you're familiar with, so technical debt, you're familiar with, right? So the problem with that, when you talk to management folks from the business world, is they're going, debt is fine. I mean, we just manage debt.
Can manage debt.
So it's okay to have debt. And as engineers, we're going, no, it's not. We shouldn't have this. And if we recast it in terms of risk, then that might communicate much better with managers.
Exactly. I think perhaps calling it debt has been a bad metaphor all along, because just because of what you said, business people see it and it's like, oh yeah, debt is perfectly fine.
That is the thing that we manage.
That is just a perfectly normal part of running a business, to have some debt and manage it.
Yeah. So
but risk is
scarier.
Scarier.
So maybe get them to. Oh no, we don't want any risk. Yeah.
Yeah.
Right.
So
Well,
just
we
going
have a
back to
little.
risk, for me that's a very nice metaphor, because to me kind of relates also, to those lean manufacturing concepts, with the the risks of traditional production systems where you build up inventory in big batches, and then by the time you notice a defect, you have lots of inventory accumulating in warehouses and several batches to throw away. To me, doing continuous deployment is kind of aligning itself with that principle of lean that says big batches are dangerous and risky. Therefore, you should aim to have them as small as possible. And to me, really, how this translates to software is one batch. To me, is just a bundle of commits going to production all at once. I would like ideally to reduce it as much as possible. So have the typical one piece flow metaphor of one commit pushed, one commit deployed,
Mhm.
and that really helps.
Yeah, I think it's ultimately all about testing and how early can you get feedback on it. And we've done a lot of work with types in recent years, and when you see that, the value of, oh, I changed this type, and instantly, the IDE tells me, oh, we got some squiggly red lines here. You've done something, so you instantly get feedback that's that from that
It's
test.
not going to work in
That's not
production.
going to work, and it's like, oh yeah, and that is so valuable.
Yeah. So I think the broader concept that we should dive into is you've talked about the quality gates, and uh, I think type systems are one quality gate, tests and unit tests, integration tests. But give us your take on what are the quality gates that you can have to reduce the risk of your continuous deployment.
Well, definitely there's several. Testing is the first and most obvious one. So I just want to elaborate here that by testing, I don't mean just writing unit tests, which are amazing, but they are only part of a testing strategy. If you really plan to send every single commit to production, you should have other types of tests that are at higher level of abstraction, and usually they will depend on what application you're building. So say if you're building a front end, you should definitely have some visual checks, for example, screenshot testing to compare that you didn't break the layout by introducing some CSS change or some new markup in the page. If you're building APIs on the backend side, you should definitely have contract tests to guarantee that you're not breaking compatibility with some consumer of yours. And so really this is heavily dependent on the application, but as a heuristic, I tend to use that test pyramid model, which says you should have basically nearly 100% coverage at the unit level, and then some overall sanity checks at a higher level of abstraction that guarantee that at least the critical flows of the application are working fine. So that's for the testing part. I would also say there's more checks you can do and you can automate that would otherwise be done by humans in a pre-production environment. So some of those
Because what we're
are
trying to do is take the humans out of that workflow of getting
Because
to
humans are
production.
unreliable.
Well, and it takes
exactly.
time.
and expensive.
Yeah.
And they get bored doing the same
Well,
regression tests over and over. I mean, that is also a
yeah.
factor. And then they get bored and it leads to mistakes. So it's much better to give these tasks to computers.
So real quick before we move on to the next gate,
Sure.
in this world, do QA engineers build the automated tests and contract tests, and are they engineering the automated tests instead of actually manually doing manual click through testing, or what's the role of QA in that in a continuous deployment scenario?
Yeah, that's a really good question, actually. I got it a lot, and it's one of the more interesting ones because, of course, if you don't have a pre production environment to do manual regression checks anymore, or the developers have to write all those tests because their commit will go immediately to production, that you might think that that leaves the QA engineers with absolutely nothing to do because the manual checks are not happening. the automated ones now have to be written at development time instead of later on, because there's no later on, essentially. But what I found is that it kind of frees them up to do some more interesting work. So some of that interesting work could be to think of the overall testing strategy and perhaps introduce new layers of testing if the existing ones are inadequate, or even do pair programming with developers when they are focused on writing the test coverage. More importantly, though, what QA engineers can also do is, for example, work on refining the tasks and do something really important, which is manual testing, but in production environment, which is something else that is enabled by feature flags. So once you have a feature flag and you're preparing, for example, some shiny new thing to be A/B tested, you do want some basic regression checks first on it, and you want somebody to manually make sure that it fits all the requirements that are specified. So obviously the only environment that's available with continuous deployment is production, but that is not a problem, because what you can do is you can configure flags so that only specific users have access to the feature. And what QAs can do then is they can access the production environment and do those really meaningful, let's say, pre-release checks to make sure the feature is acceptable to release. And they can do this actually with much more confidence than in pre-production, if you think about it, because they have the most production-like environment of all.
Right. They're working with the production data and production systems and production infrastructure, not some potentially wrong staging environment.
So does that mean that? Well, I mean, it's just occurring to me that if you don't have that extra pre-production
staging,
I guess so, that continuous deployment allows, would it actually make it cheaper? Because you don't have that extra stuff, you just go, okay, we
potentially deal with huge cost savings, because there's a lot of typical spend on those staging environments or development environments, and if you just say, hey, our only environment is production, then you're
so there's a strong economic argument here as well
on the infrastructure cost side.
Yeah, I mean, the infrastructure is only one aspect. Think of the engineering costs necessary to make these staging environments as prod-like as possible. I mean,
because you're duplicating,
replicating databases, doing all sorts of work to get that staging environment.
Yeah, like you have to synchronize data, but of course, first you have to anonymize it, because otherwise you might run into GDPR issues. And then you have to figure out, okay, I have a third-party service here. Do they have a sandbox that I can integrate the service, the staging environment with? Is the sandbox that they use the same as their production? Can I copy data from my production to that? There's so much engineering going into these things. So I wouldn't advocate for getting rid completely of staging environments, because they're still useful for some automated tests. Like, for example, if you redeploy the infrastructure, you might want to run some post-deploy automated tests to make sure that, say, for example, your Terraform or CDK has not destroyed everything. So they can still exist, but they're usually a more scaled back version of the ones that we have today. That said, I just finished speaking to a company that completely got rid of staging, and they just go laptop production. So if you're sufficiently advanced, perhaps you can even do that.
If you've added enough kind of quality gates and feature flags and those sorts of things. So are there other gates to your continuous deployment? So we've talked about testing. What else? What Canary deploys? Tell us more about what other things we can do to make sure we're to try to not break production.
So there's a number. I hope we can cover them all, but feel free to stop me if I talk too much. So one of those is definitely automated code scanning, because that's another type of testing, in my view, that allows you to detect very common issues, like sometimes bugs, but more commonly it can flag down performance issues or accidental resource leaks that you're introducing, or even unsanitized input. So imagine that has to be checked now at every commit, because every commit is going in production. Something might slip if you have the same developer or a pair working for 8 hours a day, and they might not always remember to check for those things. So having just an automated process to do that and tell you, hey, careful now, you've introduced a vulnerability right here. Please stop before you go to production and fix it. That's
What kind
definitely a
of
lifesaver.
tools, like you said, automated code scanning? What exists for this?
Oh, I'd have to look it up because I don't remember all the names, but I think one of
There's
them was
many
Sneak.
different.
Okay.
Yeah, so
There's so
Sneak is
many.
one for security. So there's lots of different forms of these static code analysis. There's the security ones, then there's like code quality ones. There's thread leak detectors. Google, I forget the name of Google's thread leak detector, but it actually will say like, hey, this code is going to link threads, and eventually that's going to have an issue in production.
Okay.
And so many different static code analysis tools that can be applied.
Yeah.
Ultimately about reducing risk. Like they're all,
Mm-hmm.
and you can add as many as you want depending on how much risk you want to try to mitigate.
Yeah. And usually they're not so much overhead anyway. Like they might add those 30 seconds to your pipeline, but after you've set them up, really all they do is bring value. Usually, so I've never found myself having to maintain their installation or anything. So really, there's really no reason not to use them, in my opinion. And yeah, as you said, they can scan all sorts of things, dependencies that have known CVs. Right now, I have one that scans our Docker images and tells me, say, am I giving access to the root user to things I shouldn't be doing, and so on. So they can scan all sorts of things.
So we've got
And
code scanners and static code analysis, and then what else?
well, code reviews, that's a really important and sometimes controversial one. So you've heard me earlier advocate for trunk-based development, and you might ask, wait, but if I have no branches, it means I have no PRs. So when is the code review happening? This is handled differently with different companies, but so what I see is that a lot of people, let's say, associate code reviews and pull requests very heavily, where I don't think that's necessarily the case, that they should be the same thing. So I found a lot of companies, for example, that guarantee continuous code review through pair programming. And that way they get a much earlier window for checking changes because they're checking them as they are made. And you're guaranteed that the code is at least seen by one other set of eyes before it gets in production, because really there's no other moment where humans have an input in this workflow otherwise, so you have to do everything at development time. So these are two alternatives. I think they're both valid, but I tend to prefer pair programming or even mob programming because it allows for a much bigger window of feedback, and also it kind of removes some of that awkwardness and social friction of peer reviews. Say, when your colleague has made a 1,000 lines PR and maybe they were fundamentally misguided about one of the requirements, and you have to break the news to them and your heart sinks, that's just the worst. So
Yeah.
I think that awkwardness is kind of a barrier to code quality and product quality. So just sitting together, two people at one keyboard sometimes is also a very effective way
Well,
of
and
code
that
review.
fits with what we talked about a little earlier about the short feedback loop. If you've got two people right there and somebody starts going off the rails, the other person can immediately go, wait a minute, I don't
Exactly.
think that's what it is. Yeah. So,
Yeah, so continuous everything, continuous deployment, continuous testing, continuous code reviews. There's definitely
Continuous
a trend.
development.
mhm.
Yeah.
And then other quality gates.
Oh, actually,
Yeah.
before we go on, so I know like review has been like, oh yeah, this is really important. But I've also heard a lot about how there's a great deal of resistance to code reviews. And
Well, my code's perfect, so it never needs to be reviewed.
well, I wasn't talking about your
Yeah,
code.
exactly. Yeah.
No, actually, on a company level, I think when people get used to code reviews, if they, get over the issues of the right and wrong issues, I think they tend to like them. But I think the company can look at this and go, well, this is an expensive process. So is there some way that we can avoid doing that? I think there's other barriers to it. Have you encountered barriers to various code review processes?
Well, I would say the most common barrier I see is the one to pair programming, I would say. Because as a tool for code review, you could argue that it's pretty expensive. So it takes, the objection goes, it takes twice the person hours to deliver exactly the same thing.
Right. Things like that.
Yeah, things like that.
Sounds like a barrier.
It is a barrier, but I think perhaps it's something that should be reevaluated as an investment in business terms, because especially if you're switching to continuous deployment, that means you're really deploying things as soon as they are written. So you do want to put some investment in thorough checking and quality. Perhaps even if economically it didn't make sense with just continuous delivery to have pair programming, because you could always check in pre-production. Maybe with the risk and benefit trade-off, it makes more sense now.
Yeah, I think I would put it in terms of risk again rather than even investment.
Yeah.
Just say, we're reducing risk. Don't worry about the money.
Right.
Yeah, and to be honest, I don't really agree with the objection itself, because the time saved by pair programming often means it's not really a fair comparison of saying you're just delivering the same thing.
We know that. As developers, we know that. But if you go to a manager and you say, we'll put 2 people on this instead of 1, the arithmetic is really simple for them. They're going, that's twice as much.
Yeah.
I can do, and so there's the resistance. And so I think if you go, we're doing this for risk, I think if we start putting everything in terms of risk, then the communication will be much better.
Yeah, indeed. I mean, I come from a consultancy that heavily advocates for pair programming, but also has to sell people's time. So we really often find ourselves in the position of, hey, we'd like to sell you this team, but with the caveat that our engineers are only going to work in pairs. So you really need this many people for whatever you wanted to deliver. So I have to have this conversation really often. And putting it in terms of risk is definitely the best strategy here. And, sometimes you can't start right away. But you might be able to progressively warm people up to it by showing, hey, let's have pair programming days, and showcasing, look, these tasks actually had this much percent rework come back on our desks. So complex conversation anyway.
Yeah. Other quality gates that you want to talk about?
Sure. So the next one I had in mind was, of course, zero downtime deployments and, sophisticated styles of deployments. I mean, it goes without saying that if you're going to deploy to production a lot of times a day, as often as you commit to main, then your deployments shouldn't show like a maintenance window, right? They should be seamless and
the
noticeable.
Site can't go down every time you do a deployment.
Yeah, exactly. So this means usually implementing something like blue-green or rolling deployments. This is really quite standard now for most, at least cloud-based applications. But, it can still happen that a company doesn't really consider it until it's time. Anyway, I would consider that a prerequisite. And
so I have a question about continuous deployment with blue-green or canaries or whatever style. Is the simplest model is that every commit gets out to prod and all of prod. But in blue-green or canaries or other forms of that, there's some progression to the whole environment. And how does that fit with when you've got your production system that some of it is on one commit and some of it is on another commit, and you then automate the getting to all of production on the latest commit, or is there usually a manual process there, or how do you reconcile different parts of production being on different commits with continuous deployment?
All right. So that's a good question. First of all, no, there shouldn't be any manual action. That's the easiest to answer to, because otherwise, of course, it's not continuous deployment if you have some sort of gate to production, which means any switch, for example, in blue green between the blue stack and the green stack, that should be automated around some metric. Same for rolling deployments, where you're rolling out, let's say, maybe one instance at a time. For example, in a containerized environment, you would be replacing the first instance. If that's healthy, then the cluster would go ahead and continue the rollout until all instances are the new version. Normally, this is based around health checks, which can be simple or complicated. But there's also ways, as you said, to perform canary deployments, which can also be automated. So, for example, there's this tool by Netflix. I hope I pronounce it correctly. It's called Spinnaker.
Yeah, Spinnaker.
Yeah. So that one is really nice because it can connect to your existing observability system, and it can gather some meaningful metrics that you choose, say, for example, latency or error rates, and automatically figure out if your new version of the code is performing as well, at least, as the old version of the code. And then if it does, it will complete the rollout all on its own. So that can definitely protect you from regressions on things that are hard to test, like security or performance or any weird issue that you might introduce in production.
Nice. And then there's another strategy. I don't know if it's worth talking about too much, but I've heard of some companies that do like these shadow production environments where they're sending some of their traffic to essentially non-functional systems, and then they check the like SLOs or whatever of that shadow traffic, and
SLO.
Service level objective.
Okay.
So saying we need this particular service to have this latency characteristic, or so yeah, I don't know. Does that have you seen that style with like the shadow production systems? And
it's something that I've never implemented in person, but we have considered with a bunch of companies, and we always ended up reconsidering for some reasons, because first of all, it's kind of complicated to set up shadow traffic at the networking level. So you have to find where's the load balancer, can I send my shadow traffic somewhere else? But also just making a shadow clone of production tends to be pretty complicated and have some issues that are a bit hard to solve. For example, they might need to have a different configuration if they connect to a database, making them non-exact clones of each other. And now you start having differences and you don't know what you have under there. That might be, again, some risk that you introduce in switching from one to the other. Also, it works well for read-only systems, but if some of your transactions coming in are write operations, what do you do? So do you actually save the result of that somewhere? Is it the same database as production? Is it a different one? Then does it have the same capacity? Does it have the same replicas? It can get quite a bit tricky to set up something like that. And to be honest, if you have a lot of traffic anyway, if you just send maybe a 2 or 5% to maybe some just normal canary deployment, you can get similar results with minimal risks anyway. So we've always ended up not going that route, even though, it is a strategy and I did hear of it. Maybe in some cases it's necessary.
Yeah, that makes sense. Other quality gates?
Yeah, so this is my last one, I promise. That one would be observability, definitely. So, all said and done, I've made a whole spiel about testing and code reviews and automated scans, but ultimately, you can still have defects going to production, whether you're doing continuous deployment or not. So, just having a good view of that production system and having all your monitors nicely set up in a readable way, that can be just a lifesaver, because then if you do have a bad deployment, you can get notified as a developer as soon as users are hitting problems on production. So
what do you specifically mean by observability?
So, for example, having logs, traces, and metrics being sent to a collection point and then surfaced through a dashboard of your choice. So you could have Grafana, you could have Datadog, one of those tools
This is
where you can have.
measuring memory usage, latency,
Okay.
all the metrics all the production metrics that would give you some information about the
So
health
ultimately, a dashboard that a human can look at and say, oh yeah, it looks okay, or
dashboard and alerts. Yeah.
Okay, dashboard and alerts.
Yeah.
Okay.
So most of these tools are pretty smart, and sometimes they can even detect anomalies on their own, but at the very least, you can configure them so that, say, if you have a graph of perhaps failed requests over time, if there is a certain spike that looks in a certain way, they can automatically send all the developers an alert to Slack or their mobile phone, even give them a call sometimes. Of course, it's very important there to keep the noise to a minimum because nobody wants to be woken up for a non-issue at 3 in the morning. But definitely, at least during working hours, which is when you're developing and deploying anyway, that's really helpful because you might get distracted by some meeting right after you've made a push to trunk, or you might be ready to call it a day, for example, on a Friday, like we were saying before. And so you would immediately get notified, hey, something's wrong. Please either revert this or just do a fix forward. So yeah, that's definitely mandatory if we want to switch to continuous deployments to prod.
Yeah.
So, and all of these gates and all the stuff that we've talked about are covered in your book, presumably.
Yes, they are. I actually have a chapter on them. It's called You Must Be This Tall, as in you must be this tall to ride this ride because it's too fast. And continuous deployment is definitely too fast for some teams that don't quite have their testing figured out yet, for example. So it's basically a big disclaimer of a chapter from my side saying,
do
hey,
these
please
things
make
before you get to continuous deployment.
Right, because before we started recording, you mentioned that you said that continuous deployment is a spicy topic, I think is what you said.
Or there's some spicy parts of it.
Some spicy parts. What did you mean by that?
Yeah, so I don't know, maybe it's me just spending too much time on places like Reddit or Twitter, but I feel like there's this big bubble of companies that just love everything continuous, they love agile, they try to make increments as small as possible, do trunk-based, continuous deployment, and for them it's working just fine, and actually they're really enjoying this kind of workflow. But then companies outside of this bubble, sometimes they get quite scared because they've never really worked with a similar mindset. And so there's this kind of I would say, group cognitive dissonance within the industry that shows me like two very separate pictures where some people think it's just fine, and including me, of course, but for some it's honestly, like you said, you insulted their ancestors, suggesting that they might deploy without any manual gates in between. So sometimes it can get really heated, like those famous debates with trunk based versus PRs for similar reasons as well. Less manual oversight and a perceived higher risk, which actually, in my opinion, is a much lower risk. But there's maybe some missing context there of all the other quality gates that need to be in place before you can do it. And it's the same with trunk based too.
Yeah. I mean, if you're using JavaScript and Node, then you probably should be a little concerned that what you're going to get to production is going to break.
Because, yeah, it's hard to test. Yeah. Well, in my own experience as a consultant, I've found that it's really, to do it right, in my opinion, you really have to look at the culture of the company, where the company is. And often, somebody might want these grand changes, but this company may not be ready for those, and you may only be able to bring in
take some baby
small
steps.
changes. Yes, what they're ready for, and I think that's kind of essential. You can't just come in and say, yeah, everybody should be doing continuous deployment, for example, because if the company's not ready for it, it's gonna
get all these other things in place before you try to get to continuous deployment.
Yeah.
Exactly. And the good thing about this is that, none of these practices are exclusively required for continuous deployment. So You can even start with just an aim of eventually implementing it. And in the meantime, you've implemented your testing, observability, your fancy deployments, your static analysis. And even if you never even decide to turn on automatic deployments, your code base is all better for it anyway. And your delivery is healthier and you're still doing excellent continuous delivery, which is nothing to scoff at. I mean, we can start with small incremental steps with all of these nice quality gates, and then we can go as fast as we want to go, which could be continuous deployment or not, if we don't want to.
Is there a connection between continuous deployment and agile?
Thanks.
That's where you're going.
I was just about to ask that. What's your perspective on agile and lean? Well, you talked about lean already, but then Scrum and all that kind of stuff. I mean, it seems like there might be
how these relate to the actual software process.
Yeah, I guess to me it's kind of continuous deployment is kind of representing, in my view, the logical conclusion of all these practices, especially agile and lean. Like if we think about them in terms of making iterations much more frequent in order to reduce the risk of waterfall, which was big bang releases every 2 years. To me, there has been this trend. I would say maybe the past 20 years of seeing literature advocating for making feedback loops shorter and shorter. And so now we have deployments at least every week or every month and short iterations. This is, the Scrum philosophy, for example, shows something demonstrable at least every sprint. To me, continuous deployment is the shortest feedback loop you can possibly have. Like there is really nowhere to go from there in terms of fast feedback. So, we started from production being something that you only touch once in a blue moon, perhaps every few years when you want to do a release. And now we arrive at a point where with continuous deployment, you basically push something to their multiple times a day. There's companies making thousands of deployments per day on all of their microservices. So it's quite a radical shift, but I see it as like a culmination of a pretty big journey with all these philosophies and pieces of literature that have brought us here. With Lean as well, Lean, one part that everybody sometimes forgets about is that the core of Lean is really this one-piece flow of inventory. And to me, that is really exemplified by continuous deployment, because essentially, if you think of commits as your inventory, here you have a one-piece flow of commits from a laptop to production. So absolutely no inventory in between the stages of the whole value stream, which is your pipeline. So yeah, I think it fits really quite neatly with all these mindsets and ways of thinking about software.
Yeah, it is interesting to look at the kind of evolution of methodologies and how in the waterfall world it almost like there was this coupling between the software development methodology and the deployment strategy.
Exactly.
And I think that what you're saying is continuous deployment is associated with the software development methodologies in that it's about shorter feedback loops, and that's the goal of both Agile, Scrum, and continuous deployment is the way to bring that to fruition. Because you could certainly do Scrum or Agile and only have releases every 6 months if you chose to, right? And so continuous deployment says no, we can have even shorter iterations on the actual deployment side too.
Yeah, absolutely. Part that I like the most about it is what you mentioned earlier, actually, which it basically decouples deployment concerns from releasing concerns. So as a product team, it could be that your stakeholders only want to release a certain feature after a couple months, because that is the right time for the market to see that feature, say, time-sensitive events like Black Friday. But with a methodology like this, basically, that doesn't mean that you can't deploy until 2 months from now. You can deploy as much as you like and test that feature in production as much as you like, only to enable it and really release it whenever it is convenient for your stakeholders. So you are kind of uncoupling these product needs from these technical needs to keep the delta of changes smaller and smaller between your code base and your production system. So they both can take their separate ways, and if everybody does the job well, product and engineering, then they don't need to interfere with each other.
Yep, I like that. Mm-hmm. Are there other parts of continuous deployment we haven't touched on yet?
Oh, I think a lot. Let me see.
We've only touched the surface.
Yeah, honestly, I have a lot of notes, and of course I wrote a whole book about it, so there's a lot.
So to continue learning, please buy the book.
Yeah, exactly. It's on Amazon, available for pre-order. Yeah, but I think maybe the quality gates are the most important thing to touch on, and especially this difference between deployments and releases comes up quite often, because first question that I get from everyone is, oh, but how do you hide your work in progress? You don't have branches, and it goes to production. I think there's a few more changes that continuous deployment introduces, which I kind of hinted at, but they definitely make it interesting, especially as compared to continuous delivery. And the biggest change is exactly this, putting deployments in lockstep with development. So this kind of forces teams to rethink a few things. One of those things is actually the typical Scrum board, for example, where you have your columns with all of your tasks. And so when you have a gate to production, usually those columns are also mapped to physical environments where you deploy your code. Say when it's in progress, then usually that means the code is on someone's laptop. When it is in the QA phase, quote unquote, then it means it's deployed in some staging environment, waiting for somebody to look at it. And when it's done, it means it's usually waiting for production. But curiously, now you've removed the gate for production deployments. It means that whatever is already in progress, it's already in production as well. So really, what do all of these next phases mean now? So it really kind of reshuffles a few concepts that maybe engineering teams are very familiar with. Another one is, when you're doing some development is also when you're deploying. So you now have to be careful about ordering and contracts, and you have to make sure that you put safeguards in place when you lose control over when deployments happen. A typical example of this is not just ordering, but sometimes we rely on simultaneous deployments when we have a button to click in order to keep compatibility between different distributed components of a system. Say I want to change a parameter that's exchanged in a call between two systems. It means that my two versions of both systems need to be updated at the same time. And with a manual deployment, I can achieve that because I just click the button at the same time for both, and I get maybe at worst a few seconds of incompatibility. With continuous deployment, however, changes go live as soon as you develop them, so you have potentially hours in between the two. So you have to come up with some stratagems to make sure that everything is always backwards compatible with everything. Which it sounds a bit tedious, but actually then you start to realize that it makes your development process a bit more conscious and thoughtful, and ultimately kind of improves stability because you don't get even those short windows of errors anywhere. So yeah.
So you just have to assume that the backwards compatibility is something you should be doing anyways, and in continuous deployment you kind of have to be doing it. And there's tools to help with that, whether it's protos or other protocols that can evolve not in lockstep, but yeah, it seems like just a good general practice that continuous deployment almost like forces you to have to do.
Yeah, exactly. So it forces you to do practices like your first commit is always a feature flag, so that you can tuck everything behind it while it's off and not worry about backwards compatibility. Or practicing expand and contract really consciously when you're refactoring some very complex system with lots of parts that are talking to each other over the network. There's also interesting considerations about databases and for example,
evolutions
schema evolutions, those become very interesting as well. So
I'm
I mean,
sure you
these
cover
are,
that in your book. We didn't get a chance to dive into that prickly problem, but
oh yeah,
yeah.
those are very heady and detailed chapters. But
Yeah.
yeah, I've tried to make the examples entertaining at least. Just a disclaimer: those examples are all based on real things that happened to me working in teams. So they might sound ridiculous to readers, but they're definitely
But this
grounded
really
in truth.
happened.
Yeah,
Yeah.
this really happened, even though it's unbelievable. Yeah.
Huh, that's fun. And when will your book be available?
And actually, did we specify the title? Is it just Continuous Deployment? Is that the name of the book?
Yes, that's the name of the book.
Okay.
Unsurprisingly, I thought it was a nice continuity with continuous integration and continuous delivery. So I just decided to keep it simple. So yeah, you can find it on Amazon. It's called Continuous Deployment. It's got a very long subtitle. But yeah, the release date should be, I think, October. So it still has to go through the final production process with the final copy editing, redrawing the illustrations, and then it's ready. But actually, you can already read it because O'Reilly has an online learning platform. And if you have a subscription to that, you can find this one in early release version. So the kind of first draft of it, unedited still. And you can also find a myriad of other books. So yeah, I highly recommend it.
Awesome. Well, great. Well, looking forward to having that out, and I'm sure it's been a lot of work for you. So I'm sure it's something
Yes.
that people will get a lot out of.
Yeah.
Um,
Thanks so much.
and yeah, thanks for joining us. That was awesome. Definitely learned some things on that, and appreciate your insights.
All right. Have a good weekend.